Is the screen okay? Are you guys able to see the first slide?
Yeah.
Yeah.
It's fine.
Cool.
Okay, so we are live.
Pranjal, is it live?
Yes, we are
Yeah.
live. We can start with the intro. Okay, whenever you guys want to start.
Soumya?
We are live right now?
Yes.
Yeah, we are.
Good to
Yeah.
go.
So, hello, all my fellow devs. Well, the voice is echoing.
It's loud and clear. Go ahead.
Okay. I welcome you all to the Devs Summit, and I hope you all had a great experience so far in the hack and attending all insightful sessions. So, today, Soumya Ram, Regional Ambassador at Matic Networks, along with my team of blockchain experts, will take an interactive session on the blockchain technologies and its applications. So let me tell you, this webinar will target all kinds of audience, irrespective of their knowledge in this field. Throughout the webinar, we start right with the basic parts and cover till the technologies on which Matic is based on. So I like my team member Abivarshini to start with the basic parts, right?
Hi, everyone. I'm Abivarshini, also from Team Matic. Nice to have all of you here today. Um, so let's jump right into section one. Section one really encompasses the blockchain basics, its structure, and its working. Also, we'll be dealing with its applications and mainly focusing on bitcoins, as we all know. Further, we'll also discuss how bitcoins are useful and why they're valuable. I'll try my best to portray bitcoins as an application of blockchain rather than a synonym. So, hope you all learned something new today. Um, okay, let's begin with a broad overview about blockchain technology. Um, Blockchain is essentially a sequence or a list, and its order is unique to each chain. So a different order implies that it's a different chain. In the essence of it, a blockchain is really just data structures sequenced as a chain. So moving on to the components of a blockchain, there are six components, although only four are um, general. The other two are unique to the data that you store in the chain. The unique components of a blockchain are the consensus and the miners. Miners are these specific nodes which actually perform the verification process, while the consensus is just the rules that manage your blockchain. The other four major components are node, transaction, block, and chain. A node is basically any computer on the network. They can be peers or even servers, but they also contain blocks. It can be a single block or multiple blocks, but they're still considered a node. The transaction is basically the simplest method that you can perform in a blockchain. They are responsible for branching and also responsible for the growth of the chain. A block is the basic entity that actually holds the data. It's used for transactions, distributions, and also modifications. Um, the chain is the sequence, the order in which the blocks and the data is stored. So it's specific to each chain. Uh, Now, moving on to components of the block itself, we know that blocks in a sequence form the blockchain. So, to make sure that the sequence is maintained and stored, each block is given its own unique identification, which is called a hash of the block. And it also contains the hash of the previous block so that you know which the parent child relation between blocks. Hence, the entire chain is stored. So, the data stored in every block um, is anything. It's literally information. It can be anything from a number to a word to a boolean value, or it can also be entire databases. It can be an object, anything you want to store. Um, Also, due to the property of the hashing of blocks, if you pick any block from any blockchain and go all the way up its ancestors, you'll always reach the genesis block, which is the parent to all blocks, and it was created when the blockchain was invented. Also, the genesis block has is always the same block, and all blockchains lead to the genesis block. Moving on, um, we're talking about the structure of a blockchain. Blockchains have a decentralized P2P structure. They will not have a centralized server-like structure in traditional databases where all the information and data from all nodes are pushed and extracted from the main server. This is not the case in a blockchain structure because every node acts as a server. They all store data and retrieve data from each other, hence acting like peers in a community. This is mainly for security reasons, as encrypted data is partially stored in many servers as possible. So if one server is compromised, then the information is not completely lost or stolen, especially when applications of blockchain are Bitcoin, which has monetary value. It helps keep the data secure and safe. The P2P network is simply the perfect structure for blockchains. It has its limitations, but still, its advantages definitely overweigh its disadvantages. So, as you can see, the difference between a centralized and decentralized peer-to-peer network. In a centralized network, just like in normal databases, there is one server and the client server network looks like this. Whereas in the decentralized one, All nodes store data, different parts of the same data, or maybe even copies. There is not one computer that actually does the storage uh, activity. So typically, all nodes have equal power. They perform the same tasks. Especially in financial technology, the term peer-to-peer usually refers to the exchange of cryptocurrencies and assets through a distributed network. In a peer-to-peer platform, the buyers and sellers, with respect to Bitcoin, execute trades. So there are no intermediates, so it's comfortable for them to perform their tasks and transactions smoothly. Moving on to how the P2P network works, in a sense, a P2P system is maintained by a distributed network of users. Usually, they have an administrator just to keep track of where what information is stored. But other than that, the servers act alike, almost identically. We can categorize peer-to-peer systems according to their architecture. There are three main types: unstructured, structured, and hybrid. Um, P2P may have its advantages over traditional databases, but nevertheless, it has its limitations. And these limitations are overcome by scaling solutions such as Ethereum and Lightning networks, which Pranjal will discuss later. Um, as you can see, um, databases are very similar to blockchain systems in the aspect that they store data and also in the data structure form. Um, so I think you guys get the basic outline of the differences between databases and the blockchain system. The main one being the client server network uh, uh, branching in databases, and the peer-to-peer network and blockchain system, which is the major difference. Um, okay, so that summarizes our entire fundamentals of blockchains. Moving on to the application of blockchains, one major one, as we all know, is Bitcoin. And Bitcoin is one of the main reasons blockchains are so popularized. So, for a brief introduction, let's dive into how the Bitcoin was created. It was created by Satoshi Nakamoto. Um, Bitcoin basically runs on the blockchain protocol, which simply means that it's implemented using a blockchain structure. They are essentially the same thing. More precisely, Bitcoin is an extension of blockchain. It uses blockchain. Um, it's a Bitcoin, in the most loosest terms, is a digital currency which records the transactions like a normal ledger does. Um, it it's almost like if blockchain was a data structure or a class, then Bitcoin would be an object. Let's say, for example, you create a class called student, and it stored the name and the age of a student. Then Akanksha of age 18 and Sanjay of age 19 would be objects or instances of that class. Similarly, if blockchain was a class, then Bitcoin would be its object. So I think that makes that clear for you. Um, Maybe even Bitcoin can be classified as a morphed inherited class of a blockchain. Um, also, why do you think Bitcoins have value? Obviously, we need to know that because Bitcoins are exchanged with real money and also resources. Um, Before that, we need to know the significance of the term Bitcoin. Bitcoin is used to describe different ideas, mainly two, but they're very different. One idea is the one that we've discussed so far, the entire implementation of the concept of blockchain and everything that follows. The other is the name given to the currency itself. The cryptocurrency on the internet is called a Bitcoin, like rupee in India or dollar in the United States. Now that that's out of the way, we can move on to why they have value. Cryptocurrency um, has value because they follow the same rules as traditional cash. Also, they're easy to transfer, maintain, keep track of, and also very reliable. Okay, so how do they work? This is the basic flow of a Bitcoin exchange. You basically purchase a Bitcoin by exchanging it with other resources. It can be money, real estate, etc. Um, in order to conduct a transaction in Bitcoin, participants first purchase, um, exchange it with real monetary value. They mine where Bitcoin, you create new Bitcoins of your own, essentially growing the entire chain. And hashing is also something that we'll cover later on. So how do you buy Bitcoins? You can Bitcoins can be bought anywhere on the internet. I suggest uh, exchanging it on real uh, reliable websites, or you can even get it from a friend. Moving on, mining. In order to get or create new bitcoins, um, the users can trade their cryptocurrency among themselves and work as a network of miners. Moving on to transactions. In order to conduct transactions on the Bitcoin network, the participants usually run a program called a wallet. Okay, Bitcoins are not technically coins. They're just placeholders for any resource. So let's say A gives X amount of resource to B, and B gives a Y amount of resource to C. Then that transaction creates a new branch in the entire Bitcoin network. So this is how transactions take place, and transactions are one of the essential components in the blockchain network. Um, Moving on to keys and wallets, yes. So as I said, participants run a program called a wallet, and since bitcoins are not really coins, wallets are not really wallets. Bitcoin balances are maintained using private um, ownership, especially through something called keys. Keys are nothing but your username and your password, and this is how you add a further layer of security to your wallet. Um, so, in essence, wallets are just a way of maintaining your transactions and also the amount of bitcoins you receive and process and also share with others or exchange with others. Um, so that's that. Okay, so now that we've completely covered the idea of blockchain and also its application, such as Bitcoin, let's see how the entire Bitcoin network comes together. So on your far right, you'll see how Bitcoins can be exchanged with actual money and resources. So that's usually the first step that a person is supposed to make. Um, Normally. Um, and then they can use these bitcoins to probably receive other resources such as maybe get a plane ticket or I don't know, pay in restaurants, etc. Mining is also one of the major workflows where people actually create new bitcoins where verified transactions take place. And moving on, the transactions create new blocks and new branches and chains, with new users becoming a part of the entire network. Every time a new block is mined, it's broadcasted. And similarly, the entire decentralized structure is formed, and the chain keeps growing. So the consensus and network is achieved. So you can see that throughout the entire process, the entire network is formed with different users, different transactions. Especially users are formed through transactions, and the wallet plays a major role in keeping track of the entire transaction system using private keys. So this is essentially the entire process of a Bitcoin. As I said before, the limitations of the P2P network plays a major role in blockchains. So Ethereum is what overcomes all these limitations. So I'll be passing on the mic to Pranjal, who will explain in detail what Ethereum does for the blockchain system. Pranjal, over to you.
Thank you so much. That was really insightful information about the basics of blockchain. Uh, yeah, just close the screen share.
Yeah, just a minute. Yeah, go ahead, Pranjal.
Thank you so much. So, just a second. All right. So we'll be looking on the Ethereum blockchain in specific. We have already learned about the basics of blockchain and how does a blockchain network works. So yeah, let's go ahead with this. So what is Ethereum? Ethereum is a blockchain-based distributed computing platform that enables developers to build and deploy their decentralized applications. So as we learned in the first part, that we'll be building decentralized apps which are not controlled by a central authority, which are not regulated by a specific organization. So we'll be building some decentralized applications, and in order to deploy them, we need Ethereum network. So basically, this Ethereum network is a bit different from the traditional blockchain network because in the traditional blockchain network there are traditional contracts to facilitate the transactions, while in Ethereum we'll be using the smart contracts to make all the transactions, and it's actually a really big plus point why Ethereum is so popular. So moving on to the features of Ethereum, there are five main features. Uh, they are cryptocurrency, a smart contract, Ethereum virtual machines, which is EVM, DApps, and DAO. So we'll be looking in detail about them. So yeah, so here first of all, let's go on to cryptocurrency. So basically, there is a cryptocurrency which runs on the Ethereum network, which is called Ether, or short for ETH, ETH. So basically, it's a cryptocurrency which is based on the Ethereum network, and it is used to pay computational resources and transaction fees on the Ethereum network. So it's a peer-to-peer currency which can be utilized by all the peers on the Ethereum network to do transactions and to pay fees for all the resources computations. So the big question arises: why do we use Ether and not Bitcoin, which is based on the traditional way of blockchain? So what is the need of Ether? So basically, Ether can be utilized for building decentralized applications, smart contracts, and for the peer-to-peer payments. So we can use Ether for all of these. And there's a really important terminology which is the gas. We'll not be looking in detail about it, but I think you guys should know that in order to pay for the gas, this Ether cryptocurrency is really important, and it is really useful in the competition in the competition and transactions for this. So moving on to the smart contracts, which is the point number two. So what is a smart contract? Smart contract is a set of rules. It's a set of agreement. It's basically a program that facilitates the exchange of money or property. So basically between two peers, in order to if they wanna make an agreement, there's a smart contract which is basically a line of code. So basically, smart contract is just a program which can be run on the Ethereum network for making transactions. So it contains all the terms and conditions of a mutually agreed contract between the peers, as I said. So what is the key feature of smart contract? Why is it so popular? So it's basically a really important feature, which really helps us in making good applications out of it, which is it is totally immutable, cannot be altered. So once the results are verified and it is executed on the Ethereum network, it cannot be altered. Any transaction done on top of the existing smart contract is rejected totally, as the hash value doesn't match the previous block, and the transactions are blocked. Moving on to the third point, which is these are carried out between two anonymous parties. So the anonymity of the parties and peers remains, and there is no control of a central authority over the transactions. So the last point being, due to this, this reliability of the anonymity of two parties, we can say that it is a pretty trustworthy way of transacting, and trustworthy way of like uh, just trading when it comes to two peers on the same network. It can be utilized in different ways, and it can have great applications. So after smart contracts, there is basically virtual machines, which is called the EVM. These are designed to operate as a runtime environment for Ethereum-based smart contracts. So basically, all the code and all the code that you have written in the programming language, which is usually Solidity, uh, we can just we can push it onto the Ethereum virtual machine, and we can use it to run this in this environment. So it operates in the sandbox environment, as I said, and the developers code the agreement, and using this EVM, they are using the Ethereum programming language. They are uploaded, and they are processed further. So what is the working of EVM? So basically, it can be any programming language. The most popular one being Solidity, which I'll be showing a demo how to write a basic smart contract, and giving the information about the basic functions in it, and so yeah. So here we can see the features of EVM. So basically, any programming language in which the smart contract is coded is always compiled by something called bytecode. So this bytecode can be read by EVM, and they can be executed. So this EVM guarantees security by preventing cyber attacks, and it makes sure that no external intrusion is possible, and the anonymity the and it makes sure the security of the contracts is still maintained. So going to the proof of stake, like just like the previous one, there are some of the statements that we have to make sure that it's there. There are some conditions. So in order to validate a block, goal of a miner is always to produce a hash value which is less than the target value. So we all know that for each block of the transitions, miners use their resources to generate an appropriate hash by changing the nonce value. So in this way, we'll be getting a hash value, and this hash value should be always less than the target value in order to process this smart contract on a EVM. So the next two, I won't be going in details because it is out of the scope of this webinar, but we'll be looking at the basic definition of it. So DApps, which is the full form, which is the short form of decentralized applications, which is basically just the backend code which runs and it is distributed over the peer-to-peer network. And last one being the decentralized autonomous organization, which is that it is not controlled by one organization, and there is no hierarchical management when it comes to being the operations when it comes to carrying out operations in the Ethereum network. So yeah, it exists on the blockchain network where it is governed by its protocol and rely upon smart contracts. There is no hierarchical management which tampers with it. So coming back to the slides. So what happens in a smart contract? So in order to understand the flow, there's just simple steps that we can just understand. So basically, an agreement can be coded in a program. It is basically like just like normal programming. We write a code, and the results are distributed to all the peers on a network. These results are verified by all the peers on the Ethereum blockchain network, and sorry and using this once it all the results are verified, it is pushed onto the what do you call it, EVM, and the contracts are executed. And here comes the most important part: why are we using the Ethereum network? Because once it is executed, it cannot be tampered with. It is impossible to tamper with. It is impossible to change the configurations. It is impossible to change the contract. So, what are the main applications of Ethereum? What are the industries which are benefiting from this technology? So, basically, like many of the organizations are using it for voting. With Ethereum, the results of the poll can be publicly visible, and ensures transparency and democracy by eliminating all the malpractices, because it is completely tamper-proof. It is not able to rig any results. Number two being banking, because there is no possible way of a hacker to attack the system and to extract the individual information or bank details. So it is a completely so this proves to be a great application, as it ensures the anonymity of the users data. So moving on to the next slide. So third being the shipping. So basically, deployment on the using the Ethereum based network is really helpful in tracking of the packages, and if a package is misplaced, it can be easily located. And last one being the agreements. Just like the smart contracts, similar principle can be used in writing the agreements and making them tamper proof. Now, as I told you about all these, uh, we can we can easily understand the difference between the traditional contract and smart contract based on some of the key features which can be used to differentiate them both. So basically, there is no involvement of third party. In the traditional contracts, we can see that there's some sort of a government, lawyer, or an organization or a head which is overlooking all these transactions and which can make changes to it, and all the transaction has to be validated by them. While in smart contracts, there is no need to get the validation of a central authority. All the transactions can be approved by all the peers on the same network, uh, which also helps in reducing the execution time. So in the normal and traditional way, it takes about 1 to 3 days to process. Whether in smart contracts, it can be processed in minutes. So I'll give you an example. A normal Bitcoin based smart contract can be processed in around 10 minutes. So yeah, so basically in traditional contracts, most of the process is manual, while it's highly automated in smart contracts, and it is completely transparent. Like we saw this application in the voting thing, it is completely transparent. All the details are available to all the peers. There's no hiding or any sort of rigging of these details. So about the archiving and storing the previous history of transactions, it is really difficult to trace a Bitcoin, while it's really easy to get the history and archive of all the transactions of a currency which is based on a smart contract. This is really easy to uh, uh, this is really easy to get the history of the transactions. So coming to the last 2 points, which is security and cost, it is highly secured as it is based on ciphers and cryptographic security. Uh, it cannot be just uh, tampered by any hacker. It cannot be decrypted. While in traditional contracts, it can be easily stolen and can easily be misused. The cost of smart contract is fairly cheap as in comparison to the traditional contracts. So yeah, so we'll be looking at the programming language which is used for smart contract, which is Solidity and Serpent. Both of these are fairly popular, but we'll be looking at the Solidity as it is the most popular language for coding of a smart contract. It is a high-level programming language which is used for implementation of smart contracts. We'll just see a small demo. This is a code I wrote in a VS Code. You can just install the package called Solidity, install the extension called Solidity, and you're good to go, and you can just write smart contracts on your own. This is a basic one. I'll just be giving you a gist of it. So the first line, uh, first line tells us about the source code that is written for Solidity version 0.4.0. So this is to make sure that the contract does not suddenly behave differently with a different compiler version. And the keyword pragma, uh, this is this is just in general it means these are just instruction for the compiler about how to treat the code. So just looking at the code, we have the line unit store data, which actually declares a state variable called store data of type of type of unsigned integer of 256 bits. So you can just think of it as a single slot in a database which can be queried and altered by calling the functions, and it helps to manage the database. So in case of Ethereum, it's always about owning the contract. So we'll be using two functions, set and get. So these are two important functions which can be called and which can be retrieved, which can be used to retrieve the data inside this store data function. So this is just a normal algorithm to write a smart contract. You'll have to dive deep in this topic if you really want to write contracts and if you want a proper application based on it. So just ending this smart contract thing by mentioning the final advantages, which is there are no intermediaries involved. There it is highly automated. It is high speed. It is the transactions are processed in minutes, and it is fairly accurate. Now, coming to the second part. So you have learned about the basics of blockchain, the basics of Ethereum, the basics of smart contract. But all these fundamentals and all these things can create a really big problem because there are some limitations to it. So what are some of the scalability issues? What are some of the issues which are creating problem in making a large scale application or a large scale project? So basically, starting off, we have the limitation. So what do you mean by limitations? So basically, uh, when a new transaction is processed, every node adds information about its ledger. So in this way, as payment history increases, the danger of buckling the overall system really increases. So if the payment history increases the inappropriate size, it can create a situation of buffer overflow, and it can just bring down the whole system. It can just crash the whole system, and you may lose all the history and all the coins you have mined on the particular system, and the data cannot be retrieved back. So yeah, so the trustworthiness on this system will be diminished, and there are several disadvantages on the hardware side, as if the hardware fails, as there are high chances of the hardware failure, and if the hardware fails, the system is it's completely gone, and the application is completely gone. This is really connected to the block size. So basically, It's another Bitcoin scalability problem. Initially, the capacity of every block in the Bitcoin blockchain was 1 MB, and every block could contain around 2020 transactions. It was a bit of factual number. So, however, the number of transactions has increased in this network, causing another blockchain scalability problem, which is the time consumption. So, the time in these consumptions has the time in these in processing these transactions has really increased, and the process is not that feasible at all. So I don't think it will be feasible for using that much energy, and if we get such poor response times. So which is our next point, the response time. So as the time consumption increases, the response time increases drastically, and in the network, every transaction must go through a validation process, and in order to verifying these number of transactions and number of the agreements, there is a lot of time which is used in processing of these transactions, which is and moving on to our last point, which is high fees, which I already discussed, that the hardware required, if you're getting like such slow speeds, you'll need a faster graphics card, you'll need a faster power supply, you'll need a bigger power supply, you'll need a faster GPU, you'll need a faster processing units. So it will be high fees, and I don't think it will be really that feasible to mine any sort of coins based on either blockchain or Ethereum blockchain, any sort of blockchain technology. I think it won't be really feasible. So now we'll be discussing what can be a possible solution to these scalability problems. There are a bunch of solutions. The main ones in the previous in some past years we have seen is hard forks, plasma cache, soft forks, and lightning network. So these are all the technologies which has been invented to deal with the problem of scalability, but we'll be focusing on the plasma cache technology, which is being utilized by the Matic network in order to scale all these applications, in order to scale all these applications on the blockchain network using this plasma framework. So moving on to the plasma framework, what is it basically? So it's one of the main blockchain scalability solution. So it's a fact that if that it's a fact that all the blocks are connected in a blockchain. So in order to add a new transaction to the block, you'll need to download all the previous transactions. And I think we all should agree that it's not so comfortable for the users, as Ethereum is one of the most popular network for ICO launches right now, and it has around 400 GB of data up, and this number is constantly increasing. So if you're trying to just do an ICO launch, you'll have to like set up 400 GB of data on your servers, and in order to do a transaction, in order to create a new node, you'll have to retrieve all this information. So how can we solve this? So basically, it works on a layering system basis, which is adding of a new layer. This is a new layer which can be added over the root layer. So this is the on-chain layer which enables the processing of our data without overloading the main network. So the main network is completely safe, and it helps in processing the layer over a different layer which is connected to the main network. So you can imagine the main network as say root chain, and the new layer as on chain. So basically, this on chain is growing as a branch from the root chain, and these branches constantly send report back to the root chain. So all the odd chains provide chain validators, which just issue their own tokens, and it helps in avoiding frauds, and it helps in scaling all the applications which were not able to scale previously. So so as I said, Matic utilizes this Plasma framework technology, as it helps all the applications which are built to tackle this problem using the Plasma framework, and just solve the scalability problem. So so more about the how Matic utilizes this. and more on how to basically use this Plasma framework, and also more about decentralized applications, which I just brushed upon. Uh, the next the next teammate of mine, Mr. Soumya, will be taking over, and he'll be explaining you in great details. So Soumya, over to you. Soumya, your mic is turned off on the Skype. Yeah.
Yeah, it's fine now.
Yes, yes,
Yeah. So is it visible?
yes, yes.
Yeah. So in the previous two sections, you measured the blockchain basics and the Ethereum basics. Now, in this section, I'll mostly cover the what do we do at Matic Networks in particular, and then brief introduction on the D apps. So these will be the things that we'll be covering mainly in this section. What is the Matic architecture and how Matic works, various security models deployed by Matic, and a brief analysis on the BOR and the Heimdall chain and DApps. So let's talk about the Matic architecture. So basically, Matic is a blockchain application platform, and it provides a hybrid of POS and Plasma-enabled sidechains. So it's the beauty of Matic is its elegant design. So it has certain generic validation layers, layer by layer, which is separated by the execution environments, like all the Plasma-enabled chains, all side EVM chains, and in future, a layer 2 is also coming, like a layer 2 is an approach, such as the optimistic rollups. So currently, developers can use Plasma for specific state transitions, for which Plasma predicates has been written in ERC20 tokens or various smart tokens. And for arbitrary state transitions, they can use POS or both the architecture. So going to the next slide. Yeah. This is image gives you an idea about the basic three-layer architecture of Matic that is enabled. So Matic has three-layer architecture. One is staking and Plasma smart contracts on Ethereum. Second one is the Heimdall, which is also known as POS layer. And third one is the BOR layer. So yeah. What are Matic smart contracts, particularly on Ethereum? Basically, Matic maintains a certain smart contracts deployed already on Ethereum, which handle the following: the delegation management, including the validator shares, keeping a track on all validators, Plasma contracts for more VP, including all the checkpoints of site chain state, a POS-enabled staking management layer, and yeah. So going to the next slide, how is Matic POS system is different from others? So Matic is not a layer one platform, just like other blockchain staking platforms like Tendermint and Peppermint, and it depends on Ethereum as layer one settlement layer. Like basically, the layer one comprises of Ethereum only. So all the staking mechanics are synced with Ethereum smart chain smart contracts previously to facilitate all the validators of this staking. Yeah. So going to the next one. Yeah. So how Matic works, I've discussed it also in the previous sections. Like it has a three-layer architecture, staking and Plasma smart contracts on Ethereum, the Heimdall and the BOR. So basically, Matic is a hybrid POS and Plasma-enabled sidechains, both combination of POS and Plasma-enabled sidechains. So yeah, this image will give you a layout of our platform, the Matic platform, and how the core components interact with each other. So going on to the security models. Matic provides three types of security models for developer to build their DApps. One is the POS, one is the plasma security, and one is the hybrid, which is most commonly used, which is a combination of both plasma and POS. So I'll discuss each and every model one by one. So what's the POS security? So POS is provided by, it's just like a subset of Heimdall and Bohr layer, which is built on top of Tendermint. And there's a checkpoint or there is a supervision which is committed to the root chain only when two-thirds of the validators have signed on it. This two-third concept comes from when all the validators sign to this model of security, only then POS security is enabled in our platform. So to enable the POS mechanism on our platform, we employ a set of rules or staking management rules which have contracts on Ethereum, as well as a set of incentivized validators. What does incentivized validators means? Preset validators who have a great staking history in our platform to run the Heimdall and the Bohr nodes simultaneously. So the features I have also mentioned, the ability for anyone to stake Matic tokens simultaneously on the Ethereum smart contract and join the system as a validator where you can poll or you can do the staking management efficiently. On staking rewards for validating state transitions on Matic network, as well as enable penalties or slashing for activities such as double signing and validator downtime. So what is double signing? These are all type of fabrication things that are enabled these days by bots to fabricate the Matic smart tokens and disrupt the ongoing staking management to enable illegal profits. So the pause mechanism also acts as a mitigation to the data unavailability problem from our side. So, a second. Yeah. So we have a fast finality layer that finalizes the sidechain periodically. So like it's like a block diagram arranged periodically through checkpoints, has regular checkpoints through each block. And the fast finality concept helps us to build a cement sidechain state. Just I mentioned that block state blockchain, which has simultaneous checkpoints side by side. So the EVM compatible chain has few validators and faster block time with high through output. Means these sidechain enables this block concept enables for a faster block time, and also it takes few validators at the same time. So yeah, coming to the first security model, plasma. So Matic provides a plasma guarantees with respect to various attack scenarios. So basically, plasma protects us from various uh, attack scenarios that are deployed through chatbots, which disrupts the staking management. So two main cases are considered here. When the chain operator, which is the Heimdall layer, is corrupt, or the user is corrupt, whether the user is doesn't have proper validations or the user doesn't have smart contacts. So in either case, if users assets on the plasma chain has been compromised, they need to start mass exciting. Like they need to start selling all their smart tokens, ERC tokens side by side. So what Matic provides is a set of construction rules on the root chain smart contract, which can be leveraged at the time of mass exciting. So effectively, security offered by Matic's plasma contracts piggybacks. Piggybacks are like collection of your own smart contracts on Ethereum's security. So in Plasma also, user funds are not only ever at risk, but these Plasma smart contracts will only be at risk when the Ethereum totally fails. So to put in simple words, a Plasma chain is as secure as the main chain consensus mechanisms. So this can be extrapolated to say that the Plasma chain can use really simple consensus mechanism and still be safe. So this is completely a plasma safeguard, which is provided by Matic. Secondly, the third uh, the second model, sorry, the hybrid chain. So apart from the pure plasma security or the pure POS security that is possible in the D apps deployed in Matic, we have the third approach called hybrid, which combines both plasma and POS, which guarantees on some particular workflows through the D app. So I'll bit elaborate on this. So there's a gaming D app called Cryptex, which is a smart set of smart contracts have presetted into that game that describes the game's logic. So it's like a Bitcoin customized Bitcoin trading game where you have smart contracts and which gives a layout of staking management and all. So let's say the game uses its own ERC20 token to reward players. Now, the smart contracts deployed defining the gaming logic can be deployed on Matic chain side directly, which guarantees the POS to the contracts while the ERC20 token can be secured with Plasma and also guarantees a fraud-proof system throughout the whole staking management. So this is the beauty about hybrid, that it also secures all validators smart tokens side by side. It also requires a very few validators enabled to smart contracts, which smoothens out the entire staking process. Now I'll cover an insight about the BOR node. What's a BOR node? So as it says, it's a block producer implementation and acts as a sidechain operator. Sidechain VM is like it's EVM compatible as well. It's a basic get implementation with custom changes done to the consensus, like to the algorithm named as consensus. However, this will be built from the ground up and it will be lightweight and focused. So these are the main 5 components of a BOR node, which are the Matic chain, the EVM compatible VM, the fee model, the system call, and the proposers and the producer set selection. So the BOR producer layer is automatically synced with Heimdall, which selects the producers and verifies for each span and sprint. So I'll explain you what is a span and what's a sprint. Every time you start a staking mechanism on Matic, the collection of all validators for bidding up their smart tokens, the process is called span. And for sprint, the ending of the staking management with the minimal number of validators at the same time enabled through side chains is called a sprint. So it interacts the users of Matic that takes place on this side chain, which is EVM compatible as well, and also to avail the functionality and compatibility of Ethereum developing tools and applications. So in the BOR layer that is enabled that is deployed in our platform, it is both compatible with Ethereum developing tools and applications as well. So yeah. So now I'll discuss about the Heimdall layer. So the Heimdall is a Matic POS verifier layer, like a flagship Matic network POS verifier layer, which is responsible for checkpointing a representation of Matic blocks to the main chain of our architecture. It acts as a supervisor, like the checkpointing word mentions it. It acts as a supervisor for representation of all the blocks laid out in the Plasma layer to the main chain, which links to our architecture. So we have implemented these by building top. It's as you have seen in the previous slides, I've shared you the components of our platform. You might have seen it. The Heimdall layer is located over the Tendermint layer. I'll show you. This one. It's Heimdall layer, Tendermint or Peppermint layer. It's above it. So yeah. So very few blocks of BOR acts as a validator on the Heimdall layer. So it publishes the Merkle root. Merkle root is a term which is used when something is routed directly to the main chain. First of all, it validates all the blocks since the last checkpoint, like from the last checkpoint or the last supervising point, it validates all the blocks. it creates an automatic Merkle tree of all the blocks and hashes it or publishes it to the Merkle root to the main chain to start the staking. So basically, Heimdall layer handles an aggregation of blocks produced by Bohr directly fixed into the Merkle tree periodically to the root chain. So it goes like this: you have set of blocks that are pre-produced by Bohr already. Then it injects into the Merkle tree and publishes the Merkle tree root through the main root chain. So these periodic publishings by the Merkle tree are known as the checkpoints. So let's discuss about the core components of the Heimdall chain. So we have an encoder. Second one is the transactions. Third one is known as the standard text. Fourth one is types. Fifth one is validators. Sixth is the checkpoint. Seventh is the validator key management. And eighth is the anti-hander. Yeah. So if we go into deep of all the components, these are beyond the scope of this webinar, but I'll surely share the links where you can get an insight of all these 8 components of Heimdall in the description box. So now let's come to the main topic that has created a revolution in the industry 4.0. That is the creation of decentralized apps. So what are decentralized apps? Basically, they are similar to web apps, but have a decentralized storage and governance procedure. Yeah. So examples of some web apps are Facebook and Reddit. And there's a decentralized app called Steemit, which is a type of Reddit only, but a decentralized one. So going to the next slide. Why decentralized applications are so important in current industry 4.0? So the apps are right now worth of billions of dollars in terms of cryptocurrencies, not the paper currencies. So it has like 23% more value than all the paper currencies as compared with the cryptocurrencies. A chance, it gives a lot of chances for development in the field of business marketing and financial technology, like creating stock prediction models, creating or enabling forex designs. It helps a lot. Like DApps helps a lot. So it helps in decentralized banking, and it also saves a lot of brokerage charges that are faced by all the validators or all the trade or all the people who trade on every platform. So there are some examples of pre-existing DApp projects like Gnosis, which is a stock prediction platform again, and Augur. It's basically a decentralized oracle, and it also acts as a stock prediction market tool. And it is another example is called Maker DAO, which is an example of decentralized finance tool. So going to the next slide. What is so special about DApps? Like how DApps are so special. First thing, you can't turn it off permanently. Like Ethereum can fail, but and only Ethereum can be made live by the certain amount of permissions given to the selected validators. But a DApp, anyone can bring it live, and it uses blockchain to store code and data, which acts as a state, and also every one of us can have it. Like keeping a data, like it's like keeping all the data of Facebook or any social media directly with you. So I'll tell you an example, like running atop a blockchain and P2P network, like the peer-to-peer network that acts as a kind of operating system. Basically, DApps have created an innovative open source software ecosystem already, which is both secure and resilient. And it allows all the developers to create new online tools on their own, many of which have piqued the interest of all global business markets. So, going to the next slide. So, what's the main difference between a D app and a web app? So, this picture shown here is quite evident. A website requires a front end and a back end and a database, Mongo database, or any other database and API. So, basically, D app requires a smart contract license and a blockchain pre-existing on it. Like websites will store data on a separate server, usually located on their headquarters. But D apps are made up of data that users can create anywhere at any point of time. So this is a very big difference between a web app and a decentralized app. So which is the first D app ever created? So Bitcoin is officially the first D app which enables anyone in the world to download a bit of open source code and join a ready-made or pre-existing blockchain network and verifies every transactions using an algorithm named mining, which generates a lot of digital currency in the form of cryptocurrencies as a reward. So it's like a rated storage array, pre-existing rated storage array. If one of the computers or one of the simultaneous roads running the DApp software goes down, the another node is existing, which will back it up, which will resume the task automatically. So this is the beauty of a DApp. So yeah. Now I will go on a brief insight of the SCSVS. First of all, what SCSVS stands for? It stands for Smart Contract Security Verification Standard. As we have a governing authority that governs all type of illegal trading activities that take place in stock market, that is named as SEBI. Its SCSVS works like SEBI but for a Bitcoin market. So what does SCSVS stands for? Smart Contracts Security Verification Standard. So these are the basic objectives laid out by the SCSVS. So it provides a list of architects, all the developers, and all the people who are reviewing the security provided by the platforms of blockchain staking. And it helps to mitigate all the known or unknown vulnerabilities which can be created by a design fault as well. And it provides a high quality code for all these existing smart contracts to ensure security. So it's a clear assessment of how secure the smart contract is in relation with the percentage of SCSVS coverage. Like the higher the percentage of SCSVS coverage, the more friendly is that smart contract and the more reliable is that smart contract to all the validators present. So going to the next. So this is a very self-explanatory differences laid out by SCSVS, the differences between a web apps and decentralized apps. So that's all from my side. And if anyone has questions regarding this, we all three are open to take. Yeah, guys, do we have some questions?
Yes, sir. Go ahead with the questions. Okay, so the basic difference between a Bitcoin and a Ethereum is basically Bitcoin is based on a traditional based blockchain network, while when we talk about Ethereum, it's based on a smart contract basis. So yeah, that is the main difference. I talked a lot about smart contracts. You can just rewind and see that.
Also, Ethereum is the whole process, and it's the technology, while Bitcoin is just the currency and nothing
Yeah, yeah.
more. I hope that cleared it up. Any other questions? Pranjal, do you want to answer that?
Just a second. How does Ethereum work? Yeah, so I explained.
Yeah.
I explained in detail like what is the process of basic smart contract. So I can just pull up the slide again. Swami, can you close your screen share?
Yeah.
Thank you. Just a second. Yeah. Yeah. So basically, like uh, first we'll start by coding the smart contract, which can be done by first writing the program itself. Then we'll be sending that program to all the peers, and the results generated by it will be verified by all the users in the network. Then once the contract is verified and it's executed, it's the final version that we get. Then using the Ethereum virtual machine, it is it is compiled and then pushed onto a DApp, which is a decentralized application, which is a web-based model, which can be used to which can be used to deploy applications on a peer-to-peer basis. Yeah, so I didn't go deep in the smart contract code, but I gave you a bit. I gave you a small prototype. I gave you a small just there's this algorithm. So basically, like this is the function that we'll be storing the information in. This has this variable called stores data. This contains all the information that we want to get, and we'll be using two functions, set and get, to set the values, and to retrieve the values we'll be using get. So this is the basic algorithm, basic pseudocode. We just have to write the whole smart contract, which is sort of out of the scope of this webinar. So I won't be going into detail.
Okay, does anybody else have any questions?
As I said, others about the scalability problems, about the hardware usage that has been increasing in the past few years. Uh, like all these problems are like a really big problem in mining Ethereum. Like the block size are increasing, the time responses are decreasing. And in order to get those, we need a high graphic power and high processing powers. So at some point, that will not be really worth it. But in order to tackle that, we have all these solutions to it, like hard forks, soft forks, and SegWit and this plasma framework. So yeah. How is Matic different from other platforms? Soumya, can you take this? Soumya? Soumya, are you there?
Hello?
Yeah, there was a question like how is Matic different from the other scale platforms which help in scalability?
Yeah. So other platforms usually employ a layer 2 security, but we at Matic Networks enable a layer 1 security which smoothens out all the staking process managements as well as all the security models. All three of them work simultaneously to reduce the load as well as to smoothen out entire staking management entire for all the validators irrespective of their locations. So
And Adarsh asked this: do you guys see Facebook or Google making decentralized apps? Yes, of course. All the big giants, all the big tech giants, I think they'll be moving to decentralized platforms because that is really feasible and that is really the future of the networking. You must have seen the show Silicon Valley. It is based on the decentralized use of the internet. So the main character usually just wants to create a decentralized internet which is not controlled by one organization. All the peers control it, and I think all these big organizations like Facebook, Google, Twitter will be moving on the DApps platform soon. I think they are working on it.
Okay, so I think that's the end of our questions section. So I hope you all learned something new today. Thank you for being here.